Darwin now thought back to the Galapagos tortoises. They too differed from island to island. His brain began racing.
Thoughts are starting to crystallize, take shape in his mind, bit by bit, bit by bit. He starts this process he describes as mental rioting, just stream of consciousness, where he's jotting down note after note after note, thoughts as they occur to him. And finally, they converge on this one idea.
What Darwin now realized was that somehow, for some reason, species change. Originally, there must have been just one type of finch in the Galapagos. But over time, it had diversified into many kinds, with different beak shapes. The same for the tortoises. One type of tortoise must have turned into many kinds, with different shells, depending on which island they lived on. With this great insight, Darwin entered dangerous new territory. The standard view at the time was that God had created every species, and that what God had created was perfect and could not change.
But Darwin said, no, why would the Creator bother with making slightly different finches for each of these different islands that all looked alike?
The prevailing view just didn't make sense. But this was only the beginning of Darwin's revolution. He turned his attention to the fossils he had collected in South America. One was of a giant sloth. Another was of a huge armadillo-like creature. These animals were extinct. But little sloths still existed in South America, and so did smaller armadillos. What could this mean?
It dawned on him that they resembled each other, so what he had found in the ground were the buried ancestors of the living animals of South America.
So again, here was more evidence that species changed. Somehow, these ancient giants must have been transformed into the smaller creatures we see today. But what Darwin would later find out took this idea of how species change into a completely new league. In Victorian times, scientists routinely studied life forms at the embryonic stage. How these tiny forms develop from just a single cell into an entire creature has long been seen as one of the wonders of nature.
Watching a developing embryo is truly the most glorious miracle of nature. I mean, you know, no baloney.
What Darwin learned from studying the embryos amazed him. In snake embryos, you could see tiny bumps, the bony rudiments of legs. But these would never develop in the adult snake. Darwin wondered, were snakes somehow descended from animals with legs? He learned that whales, which have no teeth as adults, had them as embryos. Those teeth disappeared before they were born. To Darwin, it had to mean whales were descended from creatures with teeth. But human embryos provided the most startling evidence. Under the microscope, tiny slits around the neck were clearly visible. Exactly the same structures were found in fish. But in fish, they turned into gills. In humans, they became the bones of our inner ear. Surely, This showed that humans must be descended from fish. It's an astonishing thought.
I don't know about your ancestors, but mine included priests and, you know, the usual suspects. But the idea that all of us have fish in our family tree, I think it's amazing.
And so Darwin arrived at an astonishing conclusion, one that would become central to his understanding of the great diversity of life.
Darwin had this amazingly bold idea, the tree of life, that all species were connected. And what it meant was, if you go far enough back in our family tree of humans, you'll come to fish. If you go far enough back in the family tree of birds, you'll come to dinosaurs. So that creatures that don't look anything at all like each other are actually deeply connected. No one came close to having this idea before Darwin.
This seemed to be an explanation for the vast diversity of animals. Beginning with a common ancestor, over time, across generations, species could change dramatically. Some might add new body features. Others might drop them. Ultimately, one type of creature could be transformed into something utterly different. It's a process Darwin called descent with modification. But it all begged a question. Why? What was making creatures change? Darwin needed clues, and he found them in a very surprising place. Dogs. Big, small, fat, tall. The British have long been obsessed by them. It was a full-blown love affair in Victorian England. Even Her Majesty was dog crazy. That love affair still continues today, especially among scientists like Heidi Parker at the National Institutes of Health.
So one of the most interesting things about dogs is the kind of variation that you have. And we have dogs the size of groundhogs versus a dog like Zeppy, the Leonberger, who can get to be the size of a mule deer. If we had that kind of size variation in humans, we would have people running around the size of Barbie dolls.
In his day, Darwin knew this range of sizes hadn't come about by chance. Through a careful process of selection, dog breeders mixed different dogs with different physical traits to create new forms.
Darwin was intrigued by what he was seeing breeders doing with the domestic dog. They could select for individual traits like size or shape, and they could actually change their breed.
The Whippet, for example, had been developed to chase rabbits. It was created by mixing greyhounds for speed with terriers used to hunt small game. And then it hit Darwin. Was there a similar form of selection going on in nature, but without human interference? Could natural selection explain the great diversity of life?
It was brilliant. He took something very familiar and comfortable, for example, animal breeding, and explained that the same sort of thing was going on in nature, just at a little bit different pace and with no human guide.
But what could be carrying out selection in the wild? It was then that Darwin took a completely fresh look at nature. The Victorian view of nature was sentimental. Lambs lay down with lions. But Darwin's travels on the Beagle led him to a different view. For Darwin, nature was savage. Every creature was locked in a desperate struggle for survival, ultimately ending in death.
The scale of death in nature is absolutely horrendous. And sometimes it's not just that there's a lot of death, but that it's very unpleasant death.
But in all this brutal chaos, Darwin saw a pattern.
Darwin showed that nature was a battlefield and that everything was in competition. And this brutal battle, this war of nature, as Darwin described it, was actually a creative process.
The pattern that Darwin saw was that the creatures that survived were those best adapted to the specific environments they lived in. For instance, some could handle extremes of climate. Others were brilliantly honed killing machines, perfect for catching the available prey. Still others were perfect to evade those who might be hunting them. But how did this harsh view of nature explain the finches on the Galapagos, where Darwin observed that the birds on different islands had different beak shapes? Somehow, those different beaks must be helping the finches survive.
The finches of the Galapagos Islands have beaks of many sizes and shapes, and there's a reason for that. They use their beaks as tools. Now, if you think of the type of tool you would want to crush a seed that's very tough, but is the food that you really like, you'd want a beak like this, which is the type of beak the ground finch has.
On an island where the only food is seeds that are hard to crack, a short, powerful beak will mean a finch will survive. But on another island, the available food isn't seeds, but flowers.
If you wanted to get into narrow spaces to get pollen and nectar that are very hard to get at, you wouldn't need a big, strong beak, you'd need a probing beak.
So on a different island, where you have a different food source, you have a different beak shape. And this pattern was repeated across the Galapagos. It seems that the finches' beaks had altered to fit the diet of each particular island. And that was how one original type of finch had been transformed into many. But how had these changes come about? Here, Darwin had another clue. He could see it in his own family. As every parent knows, no two children are ever exactly the same. Charles looked different from his brother Erasmus, even though they shared the same parents. Charles's children looked a bit like him and his wife Emma. But they too looked different from each other. That was something he called variation.
He realized that not every individual was the same, stamped out like a toy from a press, but there was variation.
Darwin realized that variation must be the starting point for change in nature. In any generation, the animals in a litter are never quite the same. And in the wild, such a tiny variation might make all the difference between life and death. Two penguins, for instance, might differ a tiny bit in the